Homework number 2, plotting points and identifying quadrants. There are 2 parts to this question. The first is to identify the location of the point by using your mouse to plot the x and y coordinates. Once you are finished with that, you will then choose from the multiple choices below the graph that are off the screen to identify the quadrant where the point is located. So first you'll start by putting your mouse or your trackpad at the origin. A little gray dot will appear. From there, you move along the x-axis first to the given value, +3. Along this gray vertical y-axis line, you will move to the y-coordinate, which for us is +7. Once there, you click, and the point will become yellow. Notice the location of this point and its relationship to the 4 quadrants. They're written in Roman numerals, and they go in the direction when you're writing a cube, counterclockwise. So we can see that our point is located in quadrant 1. So when we scroll down, we'll choose the first quadrant. And that's it for the first topic. The second topic is to identify the points by writing the numbers for their coordinates. You'll notice that the black dot is somewhere on the coordinate plane, and you have to state the coordinates of that point by typing them in this answer box below. So again, you will start from the origin. You will count along the x-axis first until you line up with the black point. So for us, it will be -3. Then we will count up or down along the y-axis until we get to the exact location of the point, which for us will be an 8. So the coordinates are -3, 8. We'll type them in these boxes here and submit. On to the third topic, plotting points with a change of scale. This one is a little bit trickier because you have to estimate where this point would be located. So the point is located along the x-axis at 2.7. That means it's past 2, but not yet all the way to 3. So as we move along this x-axis, we're going to put our cursor a little bit past the 2 value, but not past the 3 value. Then we're going to go down to -9.4. So we're going to slide down along this imaginary vertical line until we get past 9, but not all the way to 10. We even want to be a little bit shy of halfway. So I'm going to slide this black imaginary point down, and it's a little bit tricky. So you have to keep your palm steady or your mouse steady, and we're just going to estimate. That's a pretty decent estimate. So once I click, the yellow point will appear. I scroll down to submit my answer, and it will show me if I'm approximately in the right location. So here it is. The green dot is their dot, and my yellow dot is underneath. So I'll show you what happens if you're not correct. So -3.2, -3.2, it's a little bit further, and then +8.8. Let's say as I'm moving up, I kind of get a little bit off center, and I move it to the wrong location. Let's see, this is the wrong location. This is not good, right? So I'm going to mark this here that I know that it's wrong, but just so that you can see what type of feedback you would get, I'm going to submit the response. So I'm going to click here to submit the answer so that you can see that that's where the correct answer should have been. And it will show you where yours is down here. And it will even tell you where you put it. You accidentally put it at -2.7. Okay, next topic. Finding basic patterns in a table. In this question, they're telling you that this is a linear relationship shown in this chart. that means that there will constantly be the same adding or subtracting pattern. That is the definition of a linear relationship. So when we look here at our x values, we see that it's constantly increasing by 1. Now the same thing has to be true in the y pattern. It either has to be decreasing or increasing constantly by the same number. So what we're going to do is we're going to try and figure out what that change in these numbers is. And since it's already told linear, and we already know it's constant, we can look between any two numbers we want. So if you don't know how to get from -4 to -2, you can choose to look at this. How do you get from 0 to 2? You add 2. So that must mean that the pattern each time is adding 2. And you can double check it and see that that's true. The next thing you need to do is add 2 to the last value so you can find the missing value. So for us, the answer would be 4. So we're going to type a 4 into the answer field here and click Submit. We'll try this one more time. Again, they tell us it's linear, so we know there has to either be an adding or subtracting pattern between these numbers. And you can choose any two numbers you want. So here, any two numbers, let me restate that are next to each other. Any two numbers that are next to each other. So from 3 to 10, that would be plus 7. So it looks as though we're going to add 7 each time here. And then 7 more to get our missing value. So we're going to type 31 in our answer box at the bottom of the screen and click Submit. Let's move on to the next topic. Increasing or decreasing, and linear or nonlinear. You're going to choose one word from each of these two relationships. The most important part of this question is for you to focus on the section of the graph they want you to look at. They only want us looking along the x-axis between the numbers +5, that's right here, and the numbers +9. So right here. This is the section they want us to look at, only this section. So in this section here, what is that black graph doing? Right? What is this black graph doing between 5 and 9? So we read a graph from left to right. We read a graph from left to right. So look at what your eyes are doing when you move from the left to the right. Your eyes are moving up. So that means it is increasing. In addition, they want to know if your eyes are going straight or along a curved path. Straight is linear, and curved is just non-linear. So we can see that between 5 and 9, the graph is increasing and straight. So it's going up and straight, and that means it is increasing and linear. So we're going to choose that option from the multiple choices. Again, the first thing you want to focus on is the interval or the section of the graph that you should be focusing on. It will always be listed up here in the question. So from -2 to +3. So we're going to scan all the way down and find the graph. The graph is here. And it is we're reading from left to right. When we read from left to right, our eyes are going up, and it is curved. So up is increasing, curved is nonlinear. So increasing and nonlinear. Let's move on to the next section. This one is about finding rates. A rate, or a slope, in this case, since the relationship is linear, is known as the change in the y patterns, so how the y numbers are changing, over the change in the x patterns. That's how the x numbers are changing on this side of the table. So some call it delta y over delta x. So you can compute it mentally like this, plus 1, plus 1, plus 1. And over here we can compute it mentally as well. Plus 2, plus 2, plus 2. Now the only thing you need to be careful of is that you are putting the numbers from the patterns in the right order in the fraction. The numerator is the pattern of the y's, the changing of the y values. And the denominator is delta x, or the changing of the x values. So our rate of change for this function in the table is 1/2. We're going to type that down here and submit. Let's try that one more time. This time, the relationship is not shown as a table. It's shown as a linear equation. And in a linear equation, if it is written in this order, where the y is alone, and on the other side of the equal sign, you have an x term and a constant term, then, and only then, if it's written in this format, or if it's written in this format, as long as y is isolated and everybody else is on the other side, wherever the x is, its coefficient is the rate of change. Wherever x is, as long as it's on the other side of y and y is isolated. So for us, here's the x, the y is alone, so this number is the rate of change, -5. So we're going to type that down here, and now we're going to try another question. Again, if the equation is in y equals mx plus b form, which this is, right, it doesn't matter what the number in the m position is, it doesn't matter what the number in the b position is, but we only focus on the coefficient of x when we're trying to find our rate of change. So for us, it would be 7/4. So we're going to type that here in the answer box, 7 divided by 4. Sometimes the rate of change might even be invisible. X is never the rate of change. The rate of change is the number that's multiplying x. And if you don't see it, it's an invisible 1. Since there's a negative sign in front, for us, it would be -1x. That's another way to write this equation. So in this example, the rate of change is -1. We'll type that in the answer box, and we'll try one more question. Again, equations written in y equals form, you find the x, you find the coefficient, you have found your rate of change. For us, it's -7/4. All right, let's move on to the next section. This time we'll practice graphing a line using that y equals mx plus b sentence. So graphing a line from slopes and y-intercepts. So in this first task, they're going to tell you the numbers separately. All you need to do is start at the y-intercept. This is the y-axis, and to intercept means to cross. So we are going to put a point at 3 on the y-axis. So for us, that would be here. And that's where we're going to start, but now we're going to move this point either up and right or down and left in any direction by following the slope. The slope is the set of directions on how to move. So slope is a set of directions. And if you do not have a fraction as a slope, you simply put a 1 in the denominator. So our rise, how we will move from this red point, is a rise of -2. So that means along the y-axis, right? How does the y change? We're going to go down 2 spaces. Then we have to move along the x-axis, the run. The delta x is 1 space. So this will be our new location. So for you, with your mouse, you will start at the origin, you will move to the y-intercept, then from there, you will rise, that doesn't always mean up, and you will run, depending on the slope. We go down 2, and then positive 1. Click, and, oops, sorry. First, let's unclick that. Click it at your y-intercept. Then you will move down 2 over 1, and there's your linear graph. So click once at the y-intercept, then follow the slope and click again. So let's try this again. First, we will plot our y-intercept. So we will go to -2 and click. A line will appear, but we don't click again until we've made the proper moves. So for us, the proper moves are rise 1 and run 2. So from here, I will rise 1 and run right positive 2. One more time. Y-intercept is positive 5. The slope is down 3. Now be careful. When you have a slope with a fraction on the side, with a negative sign on the side of the fraction, you can only use it once. You can give it to 3, or you can give it to 2. It doesn't matter which one, but this is usually the easiest one. But you cannot use it twice, because that's a totally different number. You cannot use the negative sign twice. So if I use it with 3, and I go down 3, 1, 2, 3, then the 2 has to be positive. And that makes sense. A slope that's negative should be going downhill. So let's submit this answer. Try one more time. My y-intercept is 5, and my slope is positive 2. Remember, slope has to have two values. It has to have a rise and a run. So if you only have one number, you put a 1 in the denominator. So my slope is rise 2, run positive 1. And that's my graph. Let's move on to the next section. This time you're going to do the same task. You're going to graph lines, but the information will be given to you in equation form. So instead of me saying, hey, this number is the y-intercept, and hey, this number is the slope, you have to know that. So you can take notes on the side that the y-intercept is -4, and that the slope is -1/3, and now it's just like the last task that we did. We start our graph at -4, and then we move our point. Let me move the graph down a little bit here. We start our graph by clicking -4 along the y-axis, and now we're going to move like the slope, down 1, and remember, can only use that negative sign once, and then positive 3 to the right. Down 1, positive 3. Let's try this one more time. The y-intercept for us is positive 1. So we're going to start here. Right? We're going to start here with our first click. So positive 1 is our first click. And now our slope, which is invisible, there are no digits there. So we need a rise and we need a run. And if there are no digits, you put a 1 in both locations. So I'm going to rise positive 1 and run positive 1. One last time. My y-intercept is -6 or -6. My slope has no numbers, but it does have a negative sign. So remember, when there's no numbers, you put 1s, and when there's a negative sign on the side, you give it to the numerator. So from -6, I'm going to go down 1, but then I'm going to move positive 1 to the right. All right, let's move on to our last topic. identifying a function type by only seeing a picture of its graph. So for this one, it's a multiple choice question. There are 4 choices down here at the bottom. I don't want to show you too much because I want you to learn on this one from making mistakes. So I'm deliberately going to choose a wrong answer so we can see what the feedback is. So if I think, oh, this is a cubic graph, or a quadratic graph, or a cube root graph, or a linear graph, if I think that, then it will tell me I'm correct. So down here, it says these are the incorrect choices, linear, cubic, and cube root. So that must mean that a graph that's shaped like this, going down, turning around, and coming back up, almost like it has a soft U shape, that must be called a quadratic. So I didn't know it before, but now I just learned it. This shape is a quadratic. A U shape is a quadratic. So you're going to do that every time you look at a problem. You're going to make a random guess if you've never seen it before, and then you'll learn by looking at the feedback. So this one has a V shape to it. See how it's a really sharp corner here? And that's not what a quadratic was. That quadratic had a soft U shape, so I know I should not pick quadratic. So I'm going to pick absolute value, and it says I was right. So now, mental note, quadratic, soft U shape. Absolute value, hard V shape. Good luck.